Today we're going to be installing an on-roof solar system using K2 rail and K2 Vario 2 roof hooks. On this system we're going to be fitting JA Solar bifacial panels which are 1762 by 1135, so our rails need to meet the width of our panel, including the spaces of our clamps and our outside clamps for fixing the panels onto the rail. Our first step, we need to find our rafters in the roof by removing the tiles and fixing our Vario 2s directly to the rafters and allowing this part to pass through the high point of the tile, which will enable us to grind out the back of the tile and have a nice flush finish once we're done. When adjusting our roof hooks, we like to leave a gap between the tile, so when you tighten up your fixings, you get no pressure on the tile below. To get our tiles to sit flush once we've finished, we're going to grind out the nib you get into the back of the tile, which will allow it to fit nice and flush over our roof hook. So, check you have the right side of the tile, grind that nib out. Now that the roof hooks are fitted, measure and fix your rails to your roof hooks, allowing room for your mid clamps, end clamps, and the size of your array depending on the amount of panels you are fitting. For fixing our rails to the roof hooks, we're going to be using a T-bolt with a flange nut, which will go up through our roof hook and into the channel of the rail. To keep it square, I like to keep the rails centre of the roof hook so you can see a little bit of the gap on either side. Now that your bottom rail is in place, remove the top row of tiles and fix your mounting brackets in a staggered orientation so you're not putting too much pressure on the rafters in snow loading conditions.
I see that guy who does the plumbing. He's like, so what we're going to do, we're just going to do that because...
Yeah, I like this stuff.
Funny, isn't it?
Yeah.
Oh, we can't do that. Shut up.
Right, tiles. For wiring our solar panels together, we're going to keep it in series, so labelling our cables positive on one side, which will be our negative on the other, to keep a series loop, and making sure that the cable you're using is a halogen-free, double-insulated PV cable. We're going to be using MC4 connectors. When crimping your solar cables, make sure you're using proper PV crimpers or you risk loose connections and high resistance joints, which is the main causes of fire in PV systems. To make sure no one confuses our cabling with any other cabling, we must label it with danger, live DC cable. When designing your solar system, you should always check your data sheet online or the pack of your solar panel and make sure that your maximum voltage and current input does not exceed that of your inverter. We've chosen to fit here a JA Solar bifacial panel, which should be 30% more efficient than a standard panel due to the reflectance, allowing extra generation with the backside of the panel open.
How's it going to turn?
Now, as long as your bottom rail is fitted square, you should be able to measure and square the bottom of your panel off the bottom rail, which allows your fixings to be square throughout the installation.
When fixing our loose cables to the back of our panels, we like to use our metal solar PV clips, which clip into the face of the panel and allow up to 4 cables to be tidied into each of one of the 4 slots. To clamp our solar panels down to the rails, we use a K2 clamp which sits inside of the channel and holds our panels in place, which are then tightened down between the panels and at the end of the panels. So now we need to do the irradiance tests. So we check how many megawatts per meter squared. Now we're going to check our VOC, 461 volts. Now we're going to test the short circuit current by connecting our positive and negative into our shorted out DC switch, making sure it's in the off position and it's shorted in the switch. Set it to amps. On this system, we've chosen to fit a Fox 6 kilowatt inverter, which works just solely for the PV generation. We've coupled that with a Give Energy all-in-one battery and a Give Energy gateway, which allows the house to have full house backup during the event of a power cut. We've chosen to fit Give Energy as this works well with Octopus Energy tariffs and opens you up to the Octopus Go tariff at 8.5 pence in evening charges and a 23 pence during the day. So in the winter months, when you're not getting much solar generation, you can charge your battery on an evening tariff and still cut your electricity by over 2/3.